No, sir. Yes, we can able to see.
Okay, I'll keep going. No problem. Okay, we're going to talk about this introduction to Verilog. Since there was a feedback on the previous class to talk about use Verilog. So before getting the course, so we're going to talk about today and tomorrow. Let's go a little slow. Understand the basic concepts. How to design any system, any block of design. It's a kind of different concept. Right? So I'm not going to teach what is Verilog, but how to use Verilog for designing complex block or a data path and control path. So So what is the objective? Why are we doing this? First thing, please write notes for every class. I put instructions on in the classroom. Every class of mine you attend, I want to write notes. Write should contain only bullets. Don't write stories. So write what you understand, what you didn't understand. Right? And your TA will give you instructions. Basically, you have to put that in some form somewhere in the classroom. So TA will figure it out. So you have to do with it. There's a process TA will define. And there will be a buddy review. So you have to find your own partner and review with them. So make sure you understood it properly or not, and what you have not understood. So it will be clear. So it will help you to understand the concepts and application of concepts. That's what I'm going to talk about throughout the course, right? So I will not rush. If I have not completed the entire portion, I'm okay. But I want to make sure that whatever you understand, you have to understand thoroughly. You should be really mastering that, right? So that's what to focus. The theme is concept and understanding the concept. That's a theme. And experiment and experience. That's a concept, right? So, so since you're not going to see me every day, your point of contact is going to be Asha. For all technical questions, contact Asha or post on the Telegram group. Do not call me. Right? So I'll see based on your interest. If you're interested to learn, maybe I'll try and see how I can come more often to the IT campus. If you're not interested, once in a month or twice a month. Very simple, right? So based on how do you interact, how do you ask questions. Asking questions is the right way to learn. Okay. So you're going to understand how to write Testbench. To understand how to write RTL using Verilog and how to write Testbench. So that is very, very important. And I didn't get a clear feedback on Verilog. So I'm not going to teach you Verilog come to design, but you're going to write Verilog RTL, write Testbench. Part of this class and the lab. Always the classes and lab will go hand in hand. Because I said experience, experiment, and experience. So whatever I teach, the corresponding lab will have to follow next week on the same week. You have to experiment in the lab. You have to experience if you understood the concepts or not, and you have to apply the concept, right? Right. I can give you more examples, more things, more problems I can give you, but depends on how much you can take. Right? So you understand about the design, then you code that in the lab. The subsequent lab, you will do something called synthesis. You will look at the quality of results. We'll talk about that later. Right? Myself, Asha will handle the complete labs. Any question of the labs, I'll define the labs, and she's got a first point of contact for all the labs. So I'll see if when Monday, Wednesday mornings are coming, the lab gets confirmed. We'll see that. All right, we'll talk tomorrow sometime. Okay, so getting on to it quickly, right? So what is the data path and what is the control path? So data path is nothing but a collection of components. Example, let me not read. I'm not going to read the slides. Example for data path are your registers, or flip-flops, or mux, ALU, and decoders. And do you know what are these components already? All the four components. It's just examples. There are more of them. Your adder is a data path. Your multiplier is a data path. Right? So registers, these are some of the examples which can store or move the data or operate on a data. Right? Adder operates on a data. Multiplier operates on a data. ALU operates on a data. Anything which can store or move the data or operate the data is called a data path. So please understand this definition. Any questions you can feel free to stop me at that point. Okay. or does it keep moving? So what is the control path? The path which controls data path through some control signals is the control path. So the finite state machines will call the controller for the data path. So could you give me an example from real life? What is the data path and what is the control path? Not engineering, for daily life. What is the data path? What is the control path? For example, human anatomy. You all know what is human anatomy, right? You studied science till 10th standard at least. Take a human body. What is the data path? What is the control path? So who is controlling the human body?
Brain, sir.
Very good, brain. Yeah, right. So brain or the mind? Right? It's a mind. I don't know what is mind. Mind your business, is it? That's separate. Something called a mind. I don't know which part of the body has a mind. Is it brain or it's a heart? I don't know. Ask yourself. Right. So brain controls. As we say, mind controls the body. Brain gives the control signals. You want to move your hand up or down. So the brain has to send a control signal. Or you call mind. They are one or the same. I don't know. So do you data path equal to your hand, legs, eyes, mouth, nose, whatever. It does send the signals, right? You have to sense. You have to move your hand. You have to walk, run, sleep. Brain has to tell you. If your body is tired, brain will tell you sleep. You sleep, right? You have to sleep. You have to obey. You don't sleep. So, so control path is the decision maker, right? So let's go. Let's see an example. There's an equation. You want to add four 8-bit numbers. A plus B plus C plus D. You understand what the parenthesis, right? Understand A plus B first. Add the summary sum with the C, then add with D. So A plus B, both are 8 bits. Result, add with C, and the result add with C, D with a D. And that's the end answer, whatever S or whatever. You have how many adders? You have 3 adders, right? So pretty big circuit, you have 3 adders. So can we optimize the circuit? Can we do the same logic in a different way? Okay, we'll find out. So I want to use one adder instead of 3 adders, right? And use it sequentially to add up all the 4 values. This is when we will need a state machine to control the path. State machine or a control path, right? I want to use only one adder because of the previous example. What does the word sequentially mean to you? Every line is important. What does sequential mean? Give me a real life example for sequential, not electronics, not engineering. I said, please give me one example for the term sequential in a simple English.
Is it order, any order to do work, sir?
Particular order, not any order. There's a particular order, right? Not any order. Order is ordering. You go in a queue, right? You form a line. When you're at school, they say form a line, come sequentially, right? So you go one by one, right? Descending order like that, right? Not any order, right? In some order, that is sequential, right? And you add up all the four. In electronics, what does a sequential mean? Digital electronics, what does a sequential mean?
A combination circuit which has memory, sir.
Yeah, memory. What does a memory mean?
A storage element.
Register, yeah, store. It can be register, flip-flop or a latch or a SRAM, DRAM, ROM, whatever, right? So let's see how do we do that. So yeah, you have to analyze this diagram. I'm going to keep quiet for a few minutes. Let me give 3-4 minutes. I'm not going to talk about it. I want one of you to explain me at a high level how does this circuit work. Right? So let me look at the time. 5:13. I'll give you 3 to 4 minutes. Yeah, until one of you answer, the slide will not move. We'll end the class.
Okay. Sir, can I explain this?
Yeah, go ahead. Try. There's no correct. Keep trying, right? Nobody is
Ye-
perfect, so don't worry.
Yes, sir. Okay. So this is very simple sequential circuit. Like you can see from the multiplexer select line, if you give like one after one, like it will be add. Like if you give a controller sequence as a 0, then the A input will take and it will add. Okay, the initial value it will be a 0. The output will go to the second level multiplexer, and the next sequence, if you give the second one, like the mux control signal is a 1, then it will take the second input of this multiplexer, and the A value will be added to the B, because you can see the register will store the value of A. So like that, instead of doing all the with the adders, it will be a sequentially one after one, it will add, and finally the output will come
Very
A
good.
plus B plus
Fantastic,
C.
fantastic, fantastic. So all of you, please understand. You draw a time. There is something called timing diagram. Do you all know what is a timing diagram? So I want to draw a clock. Register as a clock. Draw a clock. Draw an input A, B, C, D, and name each of these nodes. Every clock, how the node value changes. Draw a time. It's not assignment for your practice. Draw a timing diagram and find this output as a O or Y, whatever you're going to call. And every clock, how the value of the node changes, draw the diagram for your own practice. That's how you understand the design. These are secrets I'm telling you, right? Nobody will teach you in the academics. That's how you learn how to analyze the circuit. Right? Once you analyze the circuit, you know how to design. That's how you solve problems. Right? So draw in your own interest, draw a timing diagram and understand how the input goes to the output clock by clock, all internal node values. You can do that manually when you run simulations. You have to correlate that. You can see that the waveform editor, right? I'm sure you have done some wave simulation sometime or other, right? So that's how first you analyze it manually, then you look at the waveforms, you correlate. And because tool is a tool, tool can make mistakes, right? But human brain cannot mistakes. Artificial intelligence and natural intelligence. Artificial intelligence is a tool. People are worried about that. Don't worry. Natural intelligence. You're no less than MIT or a Stanford or Cambridge student, right? Keep that in mind. Natural intelligence. What is the difference between MIT student and a triple IT student? Can somebody tell? MIT is not in Chennai, they're MIT in Massachusetts, or a Stanford, or a Cambridge. What is the difference between a Cambridge or Massachusetts and a triple IT student? 1 point answer. We're all human beings, let's say age, right? Third year student or a master's student, they're the same age. Studying a different college, you're studying a different college. So what is the difference?
Those universities don't have entrance exams.
No, not really. They are trained in certain way, right? Artificial intelligence, chat GPT, you have to train the tool. It's like a tool, right? They are trained in certain way from their childhood onwards or whatever age, on their own, they're getting trained or by using that, how they build their academics, using problem solving, they're trained that they don't mug up things, right? In India, we mug up things for your JEE, you have shortcuts, right? You don't follow the process. JEE exam is all shortcuts. I don't know about GATE. Right? You don't solve a mathematics problem, probably you teach you shortcuts. So that helps, doesn't help sometimes. You have to solve the problem properly, using procedures, proper way. Right? So their brain is trained in certain way, but our brains are not trained in certain way. So, so they are trained AI tool, we are untrained AI tool. That's the only difference. If you train your brain appropriately, you become say Massachusetts or a Stanford student, right? So you are untrained chat GPT, they are trained chat GPT, that's all. You are a tool. You have to train your brain. Concepts, how do you train? Concepts, application of the concepts, problem solving. 3 ways. The education doesn't do that, right? Nobody teaches you concepts. Nobody, yeah, some faculties teach you, I agree. Not everyone. On average, I'm telling, I support academics as I told last class. I'm a big fan of academic for the research, what they are doing for the publications, patents, and everything. Big fan of many of the faculties in triple IT, right? So there are good faculties, but on average, The role of a faculty is to make the students think, not to teach. So I don't teach you, I want to train you. Right? I want to mentor you. Right? So you are an untrained AI tool. You have to apply your natural intelligence and become a trained AI tool. Right? People ask me, with AI, I'll lose my job because of AI. Yeah, you'll lose job. If you're clerical work you do, you lose your job. But if you use your NI and create new AI tools to make yourself more productive, your more jobs will get created. Right? So, so you will not lose your job because of AI. Don't worry, friends. You're going to create more jobs as long as you can think differently. Think. Right? That's a USP. Okay, one more quick example before we move in. You all know how an instruction fetch happens in a computer. You have read computer architecture courses, you have program counter, so 32-bit. First, you read the address, right? You put the adder, you increment by 4 for next instruction. Though that goes out into the program counter, next program counter, you read the address, get the instruction out. This is instruction memory, right? This is the data path of the instruction fetch. If you know these concepts, whatever you can design your own CPU. You can take a 8 bits, any CPU you can take, you can design from scratch. Try on your own. This is very simple data path, right? I have enough material to teach you how to design a CPU, but I'll not do this, not purpose of the course. How does the control path look like? Example, don't read it. There's a control logic. It gets from previous, it gets instruction, the 32-bit instruction, right? So the upper 5 bits typically, or 4 bits, is the opcode. You got to control logic, and lower 6 bits control what is the function of the instruction, add or subtract, logical shift right, whatever it is. It typically upper 6 bits are instruction. You decode that, and you generate is a jump operation, branch, or memory read write, whatever, ALU, whatever, right? You decide what is the operation. So this is a control logic. It's nothing but your finite state machine. I think Nikit was asking, is it required? Everything is required, right from Boolean algebra to Karnaugh map. What you studied right from class 10th, class 12th till your second year, anything in digital electronics you read. Look at a book called Maurice Mano. That's a Bible for you. And look at a computer architecture, whatever book you read. Right? I can give you a good book if you want. Right? I used to read a book called by Goenka, for Ram, not Goenka something. Look at any CPU book. I can show you. Look at MIT courseware. They're open source. Don't read them. Digital circuit design and CPU design. If you can master that, you master the chip design. Right? It's not VLSI, it's not embedded. It's chip design, system design. Right? When somebody says VLSI and embedded, they're cheating you. So don't fall. They are just buzzwords. What you are going to talk about system design and chip design. Okay, for next 2 years. This year, next year. Okay. So in summary, you have any block you are going to design, you are going to visualize. Remember the word visualize. Write down in your notebook. Visualize. You're going to visualize that. What is visualization? In English, what does the name visualization means? You have to visualize certain things are happening. If you know psychology, you know what is visualization. Imagine, yeah. You have to train your brain to visual look at a picture. Let's say you're seeing a trailer of a movie, right? Whatever movie is going to release next Friday, right? Tomorrow, right? You would have seen a trailer, right? So you have some idea about that. You visualize how the movie is going to be, then you decide to book a ticket or not book a ticket. The new phone is launching. Look at the product review. You look at the ads in the TV, right? They'll be very attractive. You visualize the product. Then you look at the details. The ads are visualization. Few seconds you see that in your TV, right? What is the most attractive ad for you? Couple of examples quickly. TV ad, any product, electronic, non-electronic, whatever. Which is the most catchy ad? I'll tell you an example from yesterday. Amul released an ad for Chandrayaan. I'll post it in the classroom, in the Telegram group. Remind me. Fantastic, fantastic creativity, visualization. So you tell me which is the ad which you are more attracted by it. Quick, quick, quick. This is one of you.
Clothing, sir.
Give me an ad. What is that? Which ad is that? And
Wrong.
why it is attractive?
Because the style seemed nice, so I got attracted to it, sir.
Sorry?
Because of the trending fashion.
No, no. No, the ad would have been done such a way to attract you, right? What is the job of the ad? Why do people give ad in the TVs? You see some serials or sports or something, right? Or even in, yeah, probably in your Netflix and all, the ad doesn't come mostly. Right? But in the TV, you see sports, you see cricket match or football, tennis, whatever it is. There'll be ad coming between very often. Why do they put the ad? They want customers. They want to sell the product, right? I write in LinkedIn. Why do I write in LinkedIn? It's also to post in the Telegram group, right? When I get bored, I write in LinkedIn. Why do I write?
Reach.
Reachability.
Reachability. Yes, I'm using a public relation PR. What is a PR? Right? Public relationship. I want to attract the young minds, not to get distracted, but to attract. Right? So people will start listening to me slowly. You tell me any topic, I'll give me a few days. I'll write. Right? Tell me whatever you want to learn. Forget about technical, non-technical topics. Right? Life skills, whatever, any topic. No politics, no movies. Give me general topics of your interest, recession or whatever. Right? Give me some topic. Post in a Telegram group in general discussion, non-controversial topic. Any of the soft skills, whatever you want to learn, right? So I'll write articles. Engineering also tell me whatever you want to learn, I'll write articles. Right? But give me some time. I should find time to do that. Right? I'll do that. So you have to visualize, right? Any design has a control path and data path, right? So visualize the data path first. You know that it comes second. Visualize. First step is to visualize the data path. You want to move your hand. What do you do first? Or you want to run? You want to jog in the morning. So you do a warm up, right? You little bit, right? You try to move one step. You start bend a little bit, right? What do? You're stretching your muscles. Then you start jogging, right? There are a lot of brisk space. So that's basically data path. Your hand and legs, you're checking are the right condition or not. So your hand and leg are a data path. First, you visualize the data path. Any problem given to you, visualize the data path. You lay down the data path. Then visualize the control path for that. Control path is the brain, right? So you have to have a body first. When a human, how a fetus is formed, a life cycle of the human being. When a fetus is formed in the mother's womb, or any animal, right, egg or whatever, right? So what is formed first? You studied in biology class, right? Anybody, any biology students here? Any animal or any human being or fish or what, a butterfly? What comes first? What is formed first in the womb? Okay, study. If you're interested, go and look at it. Right? Data parts. Some of the body parts will form first. Slowly, brain will develop. That will be the natural. I think that will be the answer. I don't know. Look up. Right? So your control unit comes up. First is data path, then the control path. Then you generate signals appropriate to the path. Right? Your brain, you should have a leg and hand. There are some people who don't have a hand or a leg, right? Handicap, or especially what do you call special? You call them specific term. What is it called? Significantly disabled or physically challenged or something. You cannot say they're disabled, right? It's a very hurting. They're special challenged people, right? You use some particular name. Mentally challenged or physically challenged, right? You cannot say they are handicapped. That's very like hurting. So they are differently abled, something like you are using such a word, right? They don't have a hand, but can they move a hand? No. So they should have a hand, then only brain can tell move the hand, right? Should have a hand, leg, and everything first. Just an example, right? So example, it should have a data path. Then you have laid on the network, whatever signals you want. You design the control unit to program the data path appropriately. Right? And you have inputs and outputs for any block. And you have a clock and reset, very important, right? Data path contains registers, storage elements. Control path contains substrate machine which contains flip-flops. So clear is a reset, clock. Any sequential logic will have a clock and a reset. That's what it has, right? And it has an input and output each other. Now let's look at example. Any questions, guys? You have 20 more minutes to go. Okay, let's go. Have a meeting at 5:50 sharp and 6 p.m. sharp, so it end. Right? So you know what is the greatest common divisor? I'm not going to read this code, so it's your homework. Anyone doesn't know what is a GCD mean? GCD or a GCF? can read. I'll pause for 2 minutes. See if you can understand this algorithm. I'm using this example. For next 2 weeks, we're going to use the same example. You don't have to explain. Has any of you understood? Any one of you? Have you understood?
Yes, sir.
Very good. You teach the others. Somebody has a question. Who said yes?
I said.
Okay, whatever. The rest of the class knows who said yes. So I'm not seeing the name. So other people, please go to him if you don't have other questions. Okay. So how do we create a data path? I told first you have to create a data path. How do you create? Draw a register. I'll not read again. Right? You have to draw. Write what are the registers are there. You have two inputs for adder for GCD algorithm. You need two or more numbers. In this case, we have two numbers, two inputs and one output. Right? So you have two inputs x1 and y, each is 4-bit. That's what he said. Right? It's a 4-bit. It's not said it's a 4-bit. Yeah, it's a 4-bit. That is an integer. This is 32-bit. It is Verilog or C, whatever, right? You declare the int, it is 32-bit, but this example, we're going to take only 4-bit. Okay? So it's not one-to-one. This algorithm is just a representation. It's like a pseudo code. So you have 4-bit input and 4-bit output. So you have to register them first, right? Draw a register rectangular box and input and output. Don't worry about the connectivity, right? You have three registers, two inputs and one output. So three registers, clock and reset. And you have output. And you have load signal to register, right? So you generate a load signal, right? X load, Y load, and G load. This X you are loading, so it's called XLD, YLD, and GLD, right? And that's why you have inputs and clock reset, X1, Y1, the output of register X and Y, and that go to re-register, you get a G load, and the output will go to the GCD. Hope this is clear. I'm going to next slide. Any questions, please ask. Now what we do? Now we have to define the combination blocks to implement necessary algorithm, or so this is the algorithm what you have. So what are the operators we have here? Can you please answer? How many operators are there in this particular thing? This particular code? Please start. What are the operators you can see? I need answers.
Minus, plus,
Where is plus? Where is plus, man? Wrong answer. Plus is the wrong answer. Minus correct.
logical operators.
Logical operator. This is logical operator. That's correct. This is also logical operator. So two logical operators, one subtractor. And what else you have? Equal to comparator, right? So we have operators. We have subtractor. So less than operator. So equal to operator. We have minus two subtractors. Right? Two comparators. Right? That's what you have here. Right? So you build the logic appropriately. Right? Don't worry about connections. So you add subtractor. You call y minus x. This one operator. Y minus x. Right? And you give a y and x to the input. And call ymx. Y minus x. X minus y. Right? Then equal flag. Less than flag. Right? That's how things are all same. Don't worry about the connections. You can make the connections on your own. Right? So any arithmetic logical operation you want, you draw the blocks and you name the output appropriately. Left, yeah. Comparator operator, equal comparator, less than flag, and y minus x and x minus y. That's all we have. Right? This is step 3. Now you have to connect. Put the algorithm and make connections. Right? So this you should be able to do it automatically on your own now. I'll pause for 2 minutes. So if we can follow at least one path, this particular path, see if you can understand. Forget about this path. On the X data path, let's understand. Can you understand this part of the logic? This particular statement, this statement, and the else statement. 1, 2, and 3. This part that corresponds to this part of the logic. The left side. This logic is this line, and this line. I'll pause for 2 minutes. think. I want to make you think. I can tell the answer, but I want you to think. This is the simplest of the design I can take it, right? Visualize the algorithm in terms of the blocks and connectivity. Visualize, use the keyword, visualize. Visualize that you're CEO of Amazon. Can you visualize yourself as CEO of Amazon? So tell me one decision you'll take as Amazon CEO. Let's say you're CEO for next 5 minutes for Amazon. Or CEO of Google, you're Sundar Pichai, right? CEO of Google, right? So what decision you'll take in next 5 minutes? You're CEO of Google for next 5 minutes. Tell me one decision which will change the world. Or change the company, take the company stock by 10% up by a decision. I have answered, man. I'll tell you. Forget about this logic. We are talking about CEO of Google now. Okay, forget this logic. You'll figure it out on your own. So tell me one decision you'll take as a CEO of Google in 2 minutes or 3 minutes. It will impact the company stock. Company stock has to go minimum up by 10%. It's business, right? You want to make money. You invest in stock market. Know how it works, right?
Google setting up a fabrication industry.
Wow. Okay. That involves a lot of investment, right? How many chips Google bake? Why would Google need chips? How they will use the chips? Google have 1+4 belong to Google, right? I have many of my senior friends are in Google. Go my LinkedIn and see my connection. I have people working in Google. I'll get them to address you. Okay. Do you want to talk to Google employees? Senior people in Google. Name companies where you want to talk. I'll get people to come and talk to you. Say hi with you for half an hour, one of the weekends. Not weekdays, weekends. But don't ask them for employment. On that condition, I'll get them and talk to you on any topic what you want. Okay. For that, first 1 month, you have to create that confidence in me, so that I'll expose the contacts. Right? But you cannot ask them for a job. So I'll tell you one decision what I would do. Right? I'll cut 5% of the employees. Google has, let's say there are 5,000 employees, for example. I'll cut 5% of the employees. I'll send them home. Or I'll ask them to take the 5% pay cut for 3 months. Right? I'll ask them to do more work for 3 months. Work 1 hour extra. Result will be there to see in 3 months. In 1 quarter, the stock will go up. Laying off people is a pain, I know. So I said I had a negative mindset. I corrected myself immediately. See, right? I'll request my employees to work for 1 hour additional day in a productive way. Smart work is a slog work. Go and look at my LinkedIn. Connect with my LinkedIn if you're not connected. Right? Smart work and slog. I'll have to do a smart work. It's 8 hours a day, work for 9 hours a day for 3 months, 1 quarter. I'll give them stretch goals. You know what is a stretch goal, right? You're used to jog for 3 kilometers a day, and then you jog for 5 kilometers a day, so 3.5 kilometers a day. Depends on person's body condition and everything. I'll set a different goal for different people. Right? So you sleep for 8 hours a day, I'll tell you sleep for 7.5 hours a day. Possible, right? So you eat two plates of rice, or I eat 4 rotis, I eat 3 rotis. Efficiency, right? The body can still survive. So 4 rotis, you can eat 3 rotis and survive. You save some food for the poor. You can donate the food, right? Similarly, I'll ask people to work for 1 hour additional. For 3 months, the stock will go up. Announce it to the public. This is what we are going to do. We are going to solve some problems. Immediately, market will react. People will buy stock, supply and demand in economics. Okay. So similarly, you visualize this and take decisions. Right. That's what we are going to see. How do you take decisions? This slide is almost same. I'll skip this. Right. Now you have to, once you do that, you have to draw this kind of diagram. Now you have these control signals in this previous diagram. All the signals are named. Right. So you name all the control signals. You have data path, which is already here. This is your data path. all those signals are, all this logic is within this particular block, and these are input and outputs. And this block you are going to design now, right? The brain behind the GCD block you are going to design in the next slide. You know what are the signals? You know what is the data path and control path unit, right? And you know what are the various blocks. Okay. So can you visualize this from the previous block? This block to this block. Yes or no? It's not visualization. I'll write about visualization. Remind me tomorrow. I think we should have some time tomorrow. After our class, I can write on visualization. One of you please, the class up is ping me the telegram tomorrow. I'll write about visualization.
Okay, sir.
So you have to visualize this. So you go and look at slides of the classroom, you visualize this. Okay. So this diagram is homework. I'm not going to talk about it. You should know what is a state machine. If you don't know, go and read that basic textbook. Your job is to design this particular state machine based on the requirements of this timing diagram. You have to draw a timing diagram. I told you what is the timing diagram. You have to draw the timing diagram. Once you have a timing diagram, you could draw this particular state machine automatically. It will come to you. Well, you know what when the signal has to be active or not active based on the algorithm, right? Based on when the load signal should be active, when the left shift this is output anyway, right? When the inputs are to be active, right? When the load has to be active, what are the inputs? XM cell, XMM cell, XLD, YLD, GLD. These are inputs. These are outputs. So you can draw a timing diagram for all the inputs when the outputs will be asserted. Once you have the timing diagram drawn, you can design this logic automatically. That's what the approach. This is called microarchitecture. I'm going to post in the classroom how to design. There'll be new terms will be there. I have a slide. I purposely disable the slide. I'll post in the classroom, the reference material section. You don't have to understand that, but there is a process to do design. There's a process for everything. Right? Process. What is a process? Give me a general example. Non-engineering process. What do you mean by process? In your day-to-day life.
A step to do complete a work.
No, give me an example. Give me an example for a process. How many of your foodies here that eat food? Anyone knows how to cook food? No? Yes?
Only Maggie, sir.
Okay. What is the process to cook Maggie?
First, we'll boil the water and then add the Maggie and then add the masala and keep stirring it for 10 minutes and then serve.
Very good. So can you simplify the process? Same Maggie, same example. Can you simplify the process? Very good example. I appreciate it. Very good. Now next challenge. Now that you told the answer, I'll ask you next question. That's how the human brain works. No? We're all greedy, right? You eat 2 rotis, also it's very tasty, the chana masala, rajma, whatever. So you want one more serving, right? It's also now you give me the answer, I'll give you the next question. I'm becoming more tasty about the food. So can you make a better Maggie in a faster way?
Instant noodles, sir.
Very good, very good. How do you do that? How do you do that? What is the process for instant noodles? You know what is a cup noodles?
Yes, sir.
So what is the process to make cup noodles?
We have to add boiling water and wait for lesser time.
Yeah, 1 minute, right? Similarly, if you are South Indian, look at MTR, there are so many ready-made foods are available, right? Ready-made, just dip it in a hot water now, keep it in a microwave. Your food is ready, your breakfast is ready, right? Frozen food, if you're in US, frozen food is very popular. You get idlis, you get rotis, right? You go to the supermarket, get frozen rotis. Just put a tawa, apply some ghee or oil, your roti is ready, right? Get frozen vegetables, sabjis, right? Yes or no?
Yes, sir.
It may not be good for health, that's a different story. So that's a process. Now you understand. So this, you follow the process I'll put that in an article in my. Please remind me tomorrow if you don't see it. Classroom, I'll post it. Class rep to remind me. I'll post what is the microarchitecture process, right? So we have seen this design. So you have to design. This is your logic, your homework. I'm not going to explain. If you don't draw a timing diagram, you'll know how to do this. So lab 1 and lab 2, next 2 weeks. So the due date is 7th September, not this Friday, next Thursday. Your labs are going to shift to Wednesday, I don't know, whatever you want. You have 5 more minutes. This is the last slide I have. So we have time till today is 28th. What is today's date?
24.
24th, okay. 24th, your time till 7, close to 2 weeks you have. Right? So 7 p.m. Asha will give you detailed instruction by tomorrow, 2 p.m. Right? The tasks are, these are the high level tasks. Complete the RTL coding. You create 2 modules, one for data path, one for the control path, same as this diagram. Create a module called data path, GCD data path dot, whatever name you want to give it. Data path dot v and control path control unit dot v. Create 2 modules. Right? You create a top level. DUT. What does DUT mean? What does RTL mean? Let me ask you this question. What does RTL mean?
Register transfer level.
What does it mean? Next question. Okay. Is Nikit in the class? Nikit, are you there? Okay. So, best way to learn any engineering or anything in life is ask questions. I told you in the beginning, right? How do you ask questions? Easy to ask questions, difficult to answer, right? I know that how to ask questions. That's why I'm a successful mentor today. But I don't know the answer myself. I know how to ask the right questions. How do you ask questions? What? Why? How? Please take a pen and paper and write down. What? That's called WH questions. What, when, why, how, where, how, whatever, right? And why question, please be careful to use, right? You go and ask whatever, right? Asha, why did you do that? What happened to Asha? Asha, sorry, I'm just taking your name, for example. What will happen to XYZ? I call XYZ, why did you do that? What will be the reaction? Do you have any younger kid at home? The family, small kids. Or I ask you, right? Why did you do that? Nikit, why did you do that? What will be Nikit's response? Psychological question, right? What will you do? Hey, why the hell did you do that? I'll ask you a question, right? As your faculty. I'm okay, that's why I told you I'm a friend. Did anybody ask you such question? Why did you do that? Your parents? Your elder brothers? Yes or no?
Yes, sir. We'll try to justify, sir.
Yes, you go into defensive mode, right? You justify. You don't have to justify to anybody. You just justify to yourself. Why do you justify to somebody else? No. Ask question to elders. Indian culture is wrong. You have been brought up. Even I was brought up saying you cannot ask questions. Totally wrong concept. We follow all the bad concepts of Western world. Pizzas, pastas, Valentine's Day, Friendship Day, Father's Day, Mother's Day. There are so many good concepts. Time management. They don't show private information to others. What is private is what is private. What is the private information? Can you give me an example? What you do after your class hours is private. I cannot come and ask you, what did you eat for dinner at 8 p.m.? I cannot ask my friend in US, right? They'll get offended. What is your age? I cannot ask. Right? What is your salary? No question. Why you cannot ask salary? Maybe I'll read an article, remind me. Right? So why you have to handle it? Don't ask questions, but indirectly help me understand, and then frame the same question in a different way. Same thing we can be done in a different way, right? So please ask the question in a different way. You have to ask question, but ask in a different way. Okay. You have 2 more minutes. Okay. So what is register transfer? You find out. Homework, right? DUT. What is the DUT?
Device under test.
Very good. So you have to create a DUT top level. So that is this particular block, whole block together. So you create a top level .v and instantiate both the control unit and data path. If you know Verilog, you'll know what is instantiation, right? That is a prerequisite for this class. And you have to write a test bench in a modular way. I'm going to end the class at sharp 2 minutes to go. Modular way with task and functions and self-checking. What is self-checking? Give me an example for self-checking. What is, so you are doing a mathematics, some problem you are solving. I think you are doing some GCD manually, right? How do you check that you have done that correct? Do you revise after writing your answer sheet? Example, you won't revise, you check yourself, right? Self-checking. So test bench should be self-checking means we should tell the test has passed or failed automatically, right? So design some logic into your test bench. If you run the GCD logic, it gives some, I want to give this 10 set of inputs to GCD logic, 10 set of values, whatever value I may give, or your TA may do that. I'll give 10 values, whatever I want. The test bench should check that and give the correct output. That should be self-checking. So to check it works or not work, and I'll also do the same thing for 10 set of values, right? So that should be self-checking and verify that with waveform for 10 different values. And your RTL should be synthesizable. We will talk about the next class, tomorrow's class. What is synthesizable? We'll talk tomorrow, right? So we'll go in little detail about the RTL, right? So any questions on Verilog, you can ask me tomorrow. So we have covered the thing. So let's meet tomorrow 10 a.m. right? We'll meet that. On Monday and Tuesday I'm busy. It'll be a recorded sessions. So I'll record the videos. We'll finish the class. So either you can go to a new topic tomorrow if you want, or you can have a Verilog revision class. You can ask questions. So what do you want to do for tomorrow? Want to start a new topic or you want to revise anything? I would prefer to start a new topic. What do you prefer?
So let's keep a poll in Telegram.
Yeah, create. I will not be create. No, I'll try and create. I'm a little busy. I'll try and create. Okay, very good. But you have to allow me to prepare, right? So why don't one of you do it, because I'm going to be busy for next 1 hour. I have a couple of meetings to do. One of you create the poll, or you contact among yourself. You post the answer in the Telegram. I need time to prepare, right? 10 a.m. tomorrow is not. I'll come prepared for every class. I need time. It's 1 hour. Okay. So poll and let me know in next 1 hour, right? Okay. See you guys. See you tomorrow at 10 a.m. Bye bye.